In this lesson, we're going to do adding and subtracting with rational expressions. And again, we're going to use all the rules for adding and subtracting normal fractions with just numbers, except now we have to apply it to fractions that happen to have variables in them. So again, just like a normal fraction, if I had told you to add, 2/3 plus 3/4, right? You know that you can't just add these two together because their denominators are not the same. Like 2/3 plus 4/3 is going to equal, you add the top, 2 plus 4, and the denominator stays the same. So it's 6/3, and it simplifies to 2/1 or 2. And that's doable, no changes have to be made, right? In 2/3 plus 3/4, you notice that you don't have the same denominator. So if you're adding and subtracting, you have to have the same denominator. So what you're going to have to do with numbers is you're going to have to change these fractions to have like denominators. And so if you remember, right, how you change this to have like denominators is you try to think of, I used to write these like this. And you say, okay, well, what is the least common denominator of 3 and 4? In other words, what denominator could I get these to? But you want the least, right? Because, for example, I know that if I did, let's say, I know that both of these go into 60. So 3 times 20 is 60 and 4 times 15 is 60. However, 60 is too big and you're going to have to simplify too much at the end. So when we do this, what we want to always look for is the least common denominator. And so I know the least common denominator of these two numbers is 12. So we're going to create equivalent fractions with a denominator of 12. If I multiply 3 by 4, that means I'm going to do 2 by 4 as well, and I'm going to get 8. If I do 4 by 3, that means I'm going to do 3 by 3, and I'm going to get 9. And so now I have 8/12 plus 9/12. Add my numerators, and my denominator stays the same. So 17/12 is my answer, or 1 and 5/12, or however I want to write that. However, there's a process involved here of creating equivalent fractions with like denominators, right? You have to multiply each term by what's missing from the denominator. That's what I did here by multiplying by 4 and multiplying by 3. And then you add and subtract your numerators, and you use that LCD as your denominator for your new fraction. And so we do this with numbers all the time, and you should feel pretty comfortable with that. If you're not comfortable with this, adding and subtracting numbers with unlike denominators, you definitely want to practice that on your own, or come after school for extra help. But you want to master fractions with just numbers, because now when we get to fractions with variables, it becomes more difficult. So let's start doing a couple basic ones. 1 and 2 here are just numbers. So again, we have 1/2 plus 1/3, and we have to try to get these to have like denominators. And so again, if I do it, the traditional way, I'm trying to see, okay, what denominator could I get these to, right? So I have 2 and 3, and I know that the least common denominator is 6. And so I'm like, okay, so if I want to get this to 6, what did I have to multiply the 2 by to get to 6? And it would be 3. So I'm going to do 1 times 3, and I'm going to get the numerator for that one. So 1/2 and 3/6 are equivalent fractions. They just happen to have different denominators. And now I'm going to do the same thing to this side. So 3 times 2 is 6, so 1 times 2 is 2. So 2/6 replaces 1/3. And so now I'm ready to do my addition. I know that now that my denominators are the same, that least common denominator is still my denominator, and all I do is add my numerators. And so I'm going to get 5/6 as my final answer. Now, we learned some shortcuts along the way where we don't really do all this like making of equivalent fractions. We kind of can get pretty good at this, and you can skip some steps, and we'll eventually skip steps as we move on. But right now, let's not skip anything. So we go here, and we're like, okay, we've got this fraction plus this fraction. We have 6 and 12. Well, the least common denominator is going to be 12. So what do I have to multiply to 12 to get 12? 1, right? So that just stays the same, right? But now I do the same thing to the other side. And to get from 6 to 12, I multiply by 2. So I'm going to multiply the 1 by 2, and my new numerator is going to be 2/12. So 2/12 is equivalent to 1/6. It just has the denominator we need it to have. Now I can just add my numerators. My LCD becomes my denominator, and my answer is 3/12 or 1/4. Always simplify your final answer if possible. And so that's how it works with numbers. Again, this is just a repeat. This isn't a new skill. This isn't even something you're going to be tested on. This is just kind of getting you ready and primed up to get to the harder ones, right? So now here we have some rational expressions. We've got some variables in the denominator. Notice in both cases, your denominator is the expression x plus 1. So if you're adding these together, all you're going to do is add your numerators because your denominator happens to be the same. So you've got 3 over x plus 1, and that is the sum of this fraction. I would like to say they're all going to be this easy, but they're not, right? With a subtraction problem, it becomes a little bit trickier. So again, we want to make sure we focus on this. Notice that our denominator is the same in both cases. And so I know that our denominator is going to be x plus 2. Now, when you see this minus, you have to be careful because you're subtracting the entire numerator from that, right? So it's not just minus 2x, it's minus 2x minus negative 3. So what you are going to want to do is you're going to want to kind of remember that because when you're subtracting, it's going to be x plus 1 minus 2x plus 3. Okay, so you got to be very careful with that and distribute that negative. Another way you can see that is instead of minus this parentheses, you could turn this to a plus and make it like a negative 1. And then you're sort of just distributing that negative 1. It's another way to see it, okay? Either way, when you get to here, your answer should look something like this, right? So my fraction is still not fully simplified. I know x plus 2 is my denominator, but I have to kind of simplify my numerator. So x minus 2x is minus x, and positive 1 and positive 3 is plus 4. And so there is my final answer. So we keep going now. Notice we're getting to more and more complex where our denominators are not the same. And so yet again, I'm going to show you a little bit longer way at first, and then we're going to do a shortcut, okay? And so what happens is what you want is you want your denominator to be fully factored. All of these denominators are fully factored. We'll do some later where we're going to factor them first, but these are already fully factored. But you want to kind of recognize what are the factors in these. And you notice that the factors here are, in this we have x, and here we have 6 times x. And so you basically have 2 factors here and 1 factor here. Each unique factor has to be represented in your least common denominator. So when I'm trying to figure out what my least common denominator here is going to be, it's going to be the 6 and the x. Okay, so I'm going to have to try to find a way to make these fractions, right, fractions with 6x as a denominator. So the long way would be, well, if I have 1x, right, and I want to get to 6x, well, what am I multiplying to the x to get to 6x? Well, it's times 6, right? So 1 times 6 is 6. So 6 over 6x is equivalent to 1 over x. And so that's how I convert that one, right? When I go to the second one, notice it's already 6x. So it's just 5 over 6x. And so it's going to be 6 plus 5 over 6x, or 11 over 6x. And that's your final answer. Now, how could I have done that problem and saved myself a little bit of this math and like moving, not the math so much, but like all this extra work here? Let me show you how I do these, okay? What I do is I look at my fractions and I know that I need to end up with a 6x. So I ask myself, what number is missing from here to get to the 6x, right? And I know it's 6. So that's the only thing I'm going to multiply the numerator by. Okay, so I'm going to kind of, like I do it like this. I'm going to have an equal sign. I know my denominator is 6x. So I'm going to multiply this first fraction by 6. 6 times 1 is 6. I'm going to multiply, then there's a plus sign here, right? And then the second fraction, it already has 6x, so I don't need to multiply the 5 by anything. And so now I've got 11 over 6x, and that's my answer. So let's try this next one that way, right? So if I come over to this next one and I'm like, okay, First of all, I have to figure out what my least common denominator is. I've got the factor x and the factor x plus 1. So both of those need to be represented in my new denominator. So my least common denominator is x times x plus 1. And so what happens is when I go here now to kind of work with my numerator, I know that I have to multiply this numerator 1 by whatever is not down here. So the x is down there, so what I need to multiply it by is by the x plus 1. And so 1 times x plus 1, I'm going to distribute the 1, right? It's going to be x plus 1. Now I add, and I go to the next one. And I say, okay, well, what do I need to multiply this 1 by? I already have an x plus 1 down here, so the factor that's missing is x. And so it's 1x. And so now my numerator set and my denominator set. So x plus 1 plus 1x is 2x plus 1 all over x times x plus 1. And there's my answer. And so it works. And so I saved myself a little time as opposed to coming up with equivalent fractions. Like, in other words, what I saved is what if I had done it this way? I know I want to get this to x times x plus 1. So x times x plus 1 equals that. So 1 times x plus 1 is x plus 1. I do 1 over x plus 1 here. I know that I want to get it to x times x plus 1. So I need to multiply it by x. So I multiply this one by x and I get it. And notice it's the same thing. It's x plus 1 plus x all over x times x plus 1 to x plus 1 over x times x plus 1. But again, I don't have to do all this equivalent fraction stuff. It kind of skips that step but gets me the right answer. So again, we'll do a few more and, I think it'll make sense. So again, here I look at it and I'm like, okay, what is my least common denominator? Well, it's going to be x minus 2 times x plus 2 times x minus 4. Because again, each factor has to be represented, right? And so I got x plus 2, x minus 4. So what am I going to multiply this 1 by? Obviously, I already have a denominator of x minus 2. The missing piece is x minus 4, and so that's what I'm going to multiply by. So I'm going to distribute 1 times x minus 4. I'm going to get 1x minus 4. Okay? Now, I see that I have a minus 3 here, so for me, I'm just going to change that to a plus and make it a negative 3. That's going to be a little bit easier for me to work with when I multiply. So again, I look at my denominator, it's x minus 4, and I say, okay, what's missing? Well, what's missing is the x plus 2. So now I'm going to distribute. Minus 3 times x is minus 3x, and minus 3 times 2 is minus 6. So now I've done what I need to do, and now I can just combine my like terms. My numerator is minus 2x, my denominator is minus 10, and I get x plus 2 times x minus 4. Now, at this point, this answer is correct. Okay. The thing is that if you notice that numerator can be simplified a little bit. There's a GCF in there. And sometimes when you actually simplify the numerator, you might end up getting an x plus 2 in the numerator that you can then cancel, or an x minus 4 that you can cancel. And so I already know, I know what it's going to look like because I can kind of factor in my head, and I know that I don't have any common factors, so this would be acceptable. But again, I think sometimes you never know until you do it. So if I factor out a minus 2, I'm going to get an x plus 5 up there. And so x plus 2 times x minus 4 is the answer I would get if I factored that. Again, I couldn't cancel anything out, but I have a feeling if this was a multiple choice test, this would probably be the answer that would be listed. So like on an SAT, you might get this, and that's where it comes from. So I personally just like to always factor the numerator when possible, just to rule out anything I could potentially cancel. All right, and then we're going to go to the last one. Again, here we look at we've got our denominators. We've got x minus 3 and 3x minus 4. So I know, let me kind of erase a little bit and start here. So I know that in this problem, I know that my denominator has to include x minus 3 and 3x plus 4. So I go to the first one and I multiply by what's not there. So the x minus 3 is the factor we have, we're missing 3x plus 4. And so I'm going to distribute that. So I'm going to get 3x squared plus 4x. Now here with this minus, I am going to change it from a plus and make the numerator negative like that, just because that's easier for me to do that. And then I know I'm going to multiply by the factor that's not down here, right? So 3x plus 4 is down there, so I'm going to multiply by x minus 3. And so I'm going to distribute. I'm going to get minus 2x plus 6. So again, now I'm going to simplify that numerator a little bit. I get 3x squared plus 2x plus 6. And that goes over x minus 3 times 3x plus 4. Now, again, this answer, it looks pretty complete. I'd probably just check and see, are there any factors that multiply to 18 and add up to 2? Is this something that's factorable? Unfortunately, it's not factorable. Maybe fortunately, it's not factorable. I don't know. But basically, the top cannot be factored any further than it is right now. And so this is a complete answer. So again, we'll do a few more problems. And so we're constantly asking ourselves the same question. What is the least common denominator? Is it, is the bottom fully factored? Like, is it all broken down? It is. And so I know that each factor has to be represented. So I need a 2x minus 1 and I need an x plus 2. And I'm going to multiply the x by the factor that's not at the bottom, not at its denominator. So I know I have to multiply it by the x plus 2. So that's going to give me x squared plus 2x. Now this minus here, I'm going to change it to a plus and make that next numerator negative. And so again, now I'm ready to multiply by what's missing. The x plus 2 is there, so I'm going to multiply by 2x minus 1. And I do minus 1 times 2x is minus 2x. Minus 1 times minus 1 is plus 1. So when I'm ready here, I see that these middle terms canceled, and I get x squared plus 1 over 2x minus 1 times x plus 2. And so here you have your answer. If this was a minus, this would be a difference of squares. However, it's not, so my answer I know is complete. When I get to number 10, now here, for the very first time, we see a denominator that is unsimplified. This first denominator, x squared minus 9, is actually unsimplified. This is a difference of squares. It's x plus 3 and x minus 3. And so now I have to come up with my least common denominator, right? And so my least common denominator, notice I have an x plus 3, an x minus 3, and an x plus 3. Each factor has to kind of be represented, right? So I know it's going to be x plus 3 and an x minus 3. That way the x plus 3 is represented. It shows up once in each one, so it only needs to show up once in my least common denominator. And then the x minus 3. So now that I have this, I'm ready to multiply. So when I go to multiply here times the 2, notice that both of these are represented here. So the 2 doesn't actually have to multiply to anything. When I go to the 4, I have to multiply that one by x minus 3 because that one's missing from its bottom. And so it's going to be 4x minus 12. And so now I just simplify. I end up getting 4x minus 10, and I get an x plus 3 and an x minus 3. And again, I see that the 4x minus 10 can be simplified, so I might as well try it. And it's 2x minus 5, it's x plus 3, and it's x minus 3. And again, because it didn't really factor out to anything that could be canceled, it probably wasn't necessary to do that. Both answers are correct. However, again, in a multiple choice test, you're probably going to get this one on a multiple choice. Okay? And then we'll go to our last one. And notice here we've got 3 terms that we're multiplying by. Or not multiplying, sorry, we're adding 3 terms. And so let's look at our denominators. We've got x plus 1, x minus 1, and notice here we have x squared minus 1. Well, this can be factored. This becomes x minus 1 and x plus 1. And so we know that our least common denominator, again, everything has to be represented one time. So we have an x plus 1 and we have an x minus 1. That's going to be our LCD. So we're just going to take our time and we're going to go through and multiply each one of these by what's missing. So since x plus 1 is the denominator, it's missing x minus 1. When I go to the next one, notice there's an x plus 1, so I know what's missing, or there's an x minus 1 in the denominator, so I know x plus 1 is the one that's missing. And in the third one, there's nothing missing because it has both. So let's actually do the math, right? So let's start with this one. 2 times x minus 1 is 2x minus 2. And then we've got plus, and then we've got, again, 2 times x plus 1, so that's 2x plus 2. And then the last one gets multiplied against nothing, so it's just 1. So now we have 2x minus 2 plus 2x plus 2 plus 1. So let's combine our like terms. 2x and 2x combine to 4x. Minus 2 and plus 2 cancel, leaving just plus 1, right? And I think that's everything. And then the denominator is x plus 1 times x minus 1. And so this is fully simplified. Nothing else left to do, nothing else left to cancel. And that's kind of how we do the math here with adding and subtracting.